We're back already?
Is it time?
I guess it's time.
Oh, maybe we should take another 30 minutes off?
No.
No.
Not unless I'm having a snack.
Okay, we're not. All right, we're ready. Okay, so for math, we have a couple of problems here. All right. If the gray rectangle represents the whole, what fraction does the white rectangle represent?
And explain how you decided.
Well, Mr. Schmidt.
And I just want to point out, this page of problems comes from San Francisco Unified School District, and we appreciate that. Thank you, San Francisco.
Yes, definitely. We do appreciate that. I'm really enjoying looking at this. So, of course, I don't have Mr. Schmidt's perfect line thing going on there.
Oh,
Lord,
I do not have
mercy.
perfect lines.
Well, he gets the shapes and he makes it all perfect. But we can see that this portion. So if we, how much is this portion? So, well, I'm thinking.
Well, and once we decide that, how many of those would fit inside the white area?
Yeah. So what I want to do is I look at this and I eyeball it and I say, well, if I, shoot. That's not good.
Shoot, chucks, and darns. See?
Yeah, that's not good at all, Mr.
Get the tablet
Schmidt.
over there.
I don't have it curved for my left hand.
Well, Control Z.
Yeah.
That'll take the line away.
Okay. So, if I come over here and I think... Oh, shoot!
Watch your language.
I know.
You're going to scare the children.
I'm going to scare the children. Okay. Okay, so if I go there, and so then I go here, and I go here, is that pretty close to the same?
It's close. I mean,
yeah, it's not perfect.
We went over this before we started the video, and
yeah, we were
it's not going to be perfect.
Yeah, it's not.
We weren't fussing, but
no, not between us, but we were fussing trying to find the
We were fussing
answer.
with this problem.
Yes, definitely, not amongst
So just
ourselves.
do your best. What do you think, and explain how you decided.
So if this is the whole,
No, not the cutoff part, right?
Yeah,
just the entire
the
gray
whole
bar.
Thing. If this is the whole, what is this?
Yeah. How much is the white part compared to the gray part?
What is this? Minus. Ooh. Yeah, I'm pretty bad, guys. Yeah. So,
and you guys,
what do you think?
If you don't want to chop it up like that, chop it up some other way and explain how you decided. Because, trust me, we went over this several times.
Yeah, and it's not perfect, but this is as close as I could get.
Yeah.
So,
do what you guys want to do.
Yeah, so.
And just explain how you got it.
I'm not going to tell you.
Okay.
But what do you think? Okay, so number 2. Show 2 fists in 3 different ways on these rectangles.
Write an equation to match the pictures.
Okay, well, 2 fists is cheesy easy. 1, 2, 3, 4, 5. So 2 fists, if I went right down here and I said all of this, that would be 2 fists, right? Is that right, Mr. Schmidt?
Yeah, that's right.
So I have 2 out of 5. So 2 divided by 5, remember that? That does equal
Mrs.
2
Schmidt,
fifths.
May I just say that your division symbol looks more like a percent symbol?
Oh, good grief. Good grief.
I'm just saying.
Yeah, you know what? You are absolutely right. I'm going to let you have that one, Mr. Schmidt.
Okay.
I will not do anything bad to you tonight.
Okay.
Okay, so I'm going to let you have that one. So.
There we go.
Does that work?
That looks better, yeah.
Okay, so that is 2 fifths. What would you do, Mr. Schmidt?
Well, okay, so I don't see how we can go across and do it, right? Because that's divided into 4 chunks, so we can't go that direction.
There's another way.
Well, apparently you do. Well, go ahead.
No. Have it at it. I see it.
You see it, and so whatever I do is going to be wrong because it's not going to be
Absolutely
not going to be what you do.
Oh, stop.
Okay, so I'm just saying you could highlight different areas. It doesn't have to be the first 2. It could be Oh, come on.
Well,
it could
I
be
want to
over.
point out that there are 2, 4, 6, 8 of them highlighted.
Yeah. And so I could do here and here. I don't know how I would do a different equation, though.
Yeah. So that one would work.
Yeah, and I mean, you could even do random, right? Eight chunks. 1, 2, 3, 4. Let me see. 5, 6, 7, 8. You
Yeah.
could do that.
Yep.
And you would have the same thing. So what about equations? It said write an equation to match the pictures.
They're all going to be the same.
They're all
no
2/5.
No matter what you do, it's 2/5 of it.
Right.
So, yeah. I think that's all pretty easy cheesy.
And you know what, you guys? Come up with a cooler way.
Yeah.
If you can, come up with
a
different way.
We're old. You have smarter minds. So what do you have? Okay, so use a bar model and a number line to show 3/5 of 15.
Wait,
well,
that says 3/5 times 15.
Oh, I'm sorry. I say of because it's.
I know.
Times 15.
Okay, I'm just saying.
Okay. Fair enough.
And you guys, I talk about that when we're doing reading. A lot of times your brain puts a word in.
3/5 times 15.
Yeah.
Well, Well, if I divide this into 5
But we can
parts,
we know that 3/5 times 15 is the same thing as 3/5 of 15, right?
Yeah, it definitely is.
So we could
so
look at
let's
the
go.
bar and say, hey, we need 3/5 of 15 in that bar.
So I'm going to come down here. And so first thing I like to do is cheat my way through this and find out what the answer is. So can I cross cancel? Yes. That's 1 and that's 5 goes and that's going to be 3. 3 times 3 equals 9. So I'm looking for 9. So how am I going to model that? So if I say 15 and so I go, I have 2, 3. Oh, that's not going to be good. That's going to be way too small. Okay. Alright, so I always make things way too small. Okay, so if I say 1, 2, that's 3. And
She's
that's
talking about
4.
the pieces, right, guys?
Yeah, and 5.
So now there's 5
I have
pieces.
1, 2, 3, 4, 5 pieces. And so then I take those 5 pieces and I break each one of them into 3s. Okay. And I go 1, 3, 1, 2, 3. I'm sorry, that was bad. And 1, 2, 3.
Don't forget to talk loud enough where they can hear you.
2, 3.
Okay.
Okay, so this is 1, this is 2, this is 3, this is 4, and this is 5. Okay, so now I need to take out 3 out of each of these sections. So, I did that wrong, didn't I? Holy macaroni and cheese.
Well, here. Okay, we're recording.
Hi, guys. Okay, so we are on
Number 3.
Number 3, use the bar model and a number line to show 3/5 of 15.
Or
Okay.
3/5 times 15.
Yeah. Okay. So what I'm going to do is I'm going to break this beast into 3 pieces because it looks good to me. And then inside of that...
Well, also, you said that you like to know the answer ahead of time.
Yeah,
so go ahead and multiply that.
definitely. I do.
Yeah.
Okay, so 5 goes in once.
She's canceling now, right?
It goes into
Cross-canceling.
3. 5 goes into 15. 3 times 3 times 3 is 9. So I know that my answer is going to equal 9. Okay? So, but I broke it into 3 sections, and then I'm going to break each section into 5. So right now I have 2, 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. 2, 3, 4, and 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay. And then 2, 3, 4, and 5.
So now altogether there's 15 chunks.
Let me check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pieces.
Yeah, 15 pieces.
Okay, so perfect. So I want to go back up to my purple because that was my, and I want to just make this really exaggerated so you can see my cuts. Okay? And so I'm going to go and get a highlighter. You guys don't know how much fun I'm having with all these colors. Okay, so what I want to do is, these are in sections of 5, and I want to take out 3 of them. So I'm going to say 1, 2, 3, 1, 2, 3, 1, 2, and 3. So I have 3, 3, and 3. So, I'm not sure, folks. I have 3 plus 3 plus 3, and each one of these is 3/5. Okay? So 3 plus 3 plus 3 does equal 9. And there we go.
Cool.
Perfect, Mr. Schmidt.
Very good.
Would you like to talk about that number line?
Okay, so the number line is pretty similar.
Yeah, it really is. Mr. Schmidt showed it to me earlier, and I have to admit.
Okay. So I'm just going to start with 0. And you know what? Let me switch to a different color. Okay. And I'll end with 15 because I know that we're multiplying times 15. And so let's see, about here maybe. Well, probably the way you have it broken up there, kind of. Okay. And so let me see. We are going to, well, let's look at the fraction. It says 3/5 times 15. So I know that I'm talking about something that's broken into 5 parts. So I need 5 parts. Ooh, I have 3 parts, so let's undo that.
Yeah, we need to undo that.
Let's undo that. Whoa. Okay. There we go. Okay, so I need 5 parts. So I'll still use your lines though. Let me see. 1, 2, 3. 1, 2, 3. About there. And then about here. Okay, so I have 5 parts. And now inside each of those, I need 3 parts. Because 3 times 5 equals 15. And then I just need to count by 3s. Because how many 3s are in 15? 5 of them. Label them, she says. Okay, so this would be a 3. This would be 6. 3, 6, 9. 12, 15, 18. 21, 24, 27, 30. Okay, so I would just say, okay, if I'm talking about 3/5, I need to make 3 jumps. 1, 2, 3.
And we have 9.
And I end up on the 9.
Awesome
so I know
job.
that's my answer.
Very good, Mr. Schmidt. I like it.
Okay, now we get to talk about birthday cake.
Okay, so would you like to read it for us?
Here is a piece of Rongopi's birthday cake, and we looked that up on Google to make sure we're saying it right.
Make sure we're saying it right.
Each piece of cake has the same number of candles. How old is Rongopi?
Okay, so unfortunately, somebody ate most of the pie. So.
Well, we have a piece, right?
Yeah, we have 1 piece, which will work for us. Now, I want to point out that everything has been broken up into 5s, everyone.
Talk loud enough.
If you haven't noticed, it's broken up into 5s. So I'm going to assume that that is the case. So I'm going to come over here, and I'm going to hope that that's the case. So that's 2, that's 3,
and then
1, 2,
split
3,
that one in half.
and then split this one in half. So 1, 2, 3, 4, 5. Okay, so if this one has 4, I'm going to put a big fat 4 on there. I'm going to put a 4 there, a 4 there, a 4 there, and a 4 there. How old is Rongopai? So 1, 2, 3, 4, 5. So I'm going to say 4 times 5. How old is he, everyone? And I'm going to leave that up to you.
Cool.
Okay.
Bonus
so now,
math.
let's look at our bonus math.
Remember, you guys don't have to do it.
Yeah, but I hope you do.
I hope you do, but if you don't want to because you refuse to do anything extra, okay, fine.
Yeah, but come on, guys, seriously.
The first one is just a subtraction problem.
Yeah, line it up.
Pause the video. And, yeah.
Number 2 is already lined up for you. Cheesy easy. Can't believe how easy. Number 3, find the perimeter and the area. Now, remember the perimeter, everyone.
You want to make this larger?
That'd be kind of cool.
If you're going to, like, work on it,
well,
let's make it larger.
Yeah, let's make it a little bit bigger.
Yeah.
I'm not going to do it for them because I want them to do it.
Oh, okay.
But I want to remind you that the perimeter is the area, or is the outside. So I think a perimeter as my fence in my yard. So how much fence do I need? Now, over here, you know, this is 3, and it's the same over here. So we can easily say that this is 3 centimeters, okay?
What other piece are we missing? We're missing another piece.
Let me see.
Yeah, that long one.
Oh, this long one.
We're missing that long one right there.
Definitely. Oh, I'm sorry. So totally.
What I'm saying is, before you do perimeter, you have to make sure every side you account for.
Is accounted for, absolutely. So these 1 centimeters is this length right here. So this whole distance along here is 10. But we have 1 taken away here and 1 taken away here. So what is 10 minus those 2? This area right here, from here to here.
And we don't want to say area.
I'm sorry. The length must equal 8 centimeters. Okay? So, for perimeter, you are going to add up all of the fencing. Now, area. Area is a different type of squirrel. Okay, so what we're going to do for area, which is easy, I like doing area. It's kind of like a puzzle.
We need to break it up into pieces.
You have to break it up into pieces. Okay? And so what we're doing here, area here is kind of like a multiplication chart. What is 1 times 3? It's 3. So this one here is the same thing. 1 times 3 is 3. Well, this one here, this whole thing is 3. But we have 1 taken out of here. So what is 3 minus that 1? This is going to be 2 centimeters here. Okay? Which means it's the same over here, 2 centimeters. We don't need that.
Area is length times width.
Yeah. So the length times the width. What is 8 times 2? It is 16. Okay. So.
And that would be square centimeters.
Yes, yes.
Because you just...
Yeah.
So we should write a squared up there. Yeah.
Okay.
No.
Oh.
Yeah. No, this isn't square centimeters, right? This is a length measurement.
I'm sorry.
But when she said 8 times 2, that's 16 square centimeters. Now, this is the area of this piece of... Oh, my Lord.
Mm-hmm.
You stop yourself. Okay, this area inside
is 16
this...
square.
16 square centimeters.
I'm sorry. I apologize because what I meant to do was up here. 3
That's 3 square centimeters.
Centimeters square.
Yeah.
And so 3...
Maggie's trying to come in.
Okay. So, in order to do the centimeters, I'm going to take this 3 plus that 16.
Hi,
plus that 3, and it's going to equal something centimeters square. So what is 3 plus 16 plus 3 more? That is going to be the area of this, because what I'm looking at for area is what is the inside, okay? Okay, so that is how you do that. Could we look at the next one, number 4?
Sure. I just had to let my doggy in. She was knocking on the door.
Yeah, she's a sweet baby. She does knock on doors. She's cute.
Okay. Number 4.
Okay, which
of these fractions
is greater? So we're comparing. I do not want you to eyeball this. I want you to find a common denominator. So I'm going to set it up for you right here. But I want you to do this. So I have 5/6 and I have 7/8. I want you to, you're not adding, you're finding common denominators. What is a common denominator for 8 and 6? I'm not going to do this because I think at this point you should be able to do this, don't you?
Yeah, they should.
Do you want me to do it?
No, I mean,
Let me know, Mr. Schmidt.
well, let's just say... No, stop. So, I'm just thinking of multiples of 6. 6, 12, 18, 24. So, I'm saying you guys should go for 24 because...
Yeah, definitely.
That's the least common multiple between 6 and 8 for me.
Okay. I think I'm going to go ahead and help him out with this.
Some people
6
would
times...
appreciate that.
Okay, so I'm going to say 24 because if we did our multiples over here of 6 and 8, let's go ahead and do that. Okay, so I have 6, I have 12, and I have 18, and I have 24. And then if I had 8, I have 8, and I have 16, and I have 24, and you can see that I have 24. Okay? So 24 is my common denominator.
And they should be able to...
Yeah, so...
Well, let's write down what we multiply times.
8 times what gave me that 24?
8 times 3.
It's going to be 3. And you know what I do to the denominator? I'm going to do to the numerator. 6 times what gave me 24?
6 times 4.
4. And I'm going to do that to the denominator, or the numerator. 5 times 4. And so you can fill that out. And you can see
which one's greater.
Which one's greater.
Yeah.
Okay. All right.
And yes, we know you could cross multiply, or some people call it the butterfly method, but it's fallen out of favor. They want you to see the common denominator and realize why it works.
Okay.
So that's why we didn't do it that way.
Okay.
Okay, number 5.
Clovertown students attend school 5 days a week for 36 weeks. Each school day is 6 hours long. How many hours do students spend in school each week? Well, guys, you have 5 days for 36 weeks, so that's pretty easy. So I'm going to look up here. I'm going to say 5 days, 36 weeks. So first thing I need to do is I need to multiply 5 times 36. So that is going to tell me how many days in that 36 weeks. And then I need to multiply it by 6 hours. So
it's going to tell you how many school days are in the 36 weeks.
Equals school days.
No.
No?
No, because they're finding out how many hours.
Oh, I'm so sorry.
Yeah, it's not going to be school days.
No,
the 5 times 36 tells you the school days.
Okay, so it's going to tell me...
It's 8 o'clock, people. My wife gets tired by this time of night.
How many hours have students spend in school? So, hours. Okay?
Yeah.
Okay.
Cool.
Are we good?
We're good.
We are good.
You guys have to multiply 2 of those numbers. You could do 5 times 6 first, or you could do 36 times 5. You could do 6 times 36. It's up to you.
I would do 5 times 6 and then multiply
30
it by
times 36, and that makes it a lot easier.
Yeah, definitely.
And the reason you can do that is because of the commutative property of multiplication.
Absolutely.
And that's it. 24 minutes, 25 minutes.
Looking good. All right, guys. See you tomorrow.
See you tomorrow, guys. Bye.